All right, so thanks to everyone who stuck around. This is our monthly Traffic Link user training session. We are focusing on the detection system today. We're going to go through a couple features. I have a little bit of an agenda I'll show you here in a second, but for those that don't know me, my name is Brent Rogerson. I'm a sales engineer on our ITS product line. I help with a lot of our customers and help them take advantage of all of our tools, make sure they're getting the maximum value out of it. So that's what brings us here to this session today, is that we can really dive into some features and functionality and hopefully provide some value along the way. So I do recognize that I usually move pretty quick into the content, and there's usually lots of questions. That's fine. Feel free to use the chat box to ask some questions. You can reach out to me directly. There's my email address, brogerson@myovision.com. You can also contact your normal channels, one of Myovision's distributors, our sales team, our support teams, whichever way you want to contact us. Feel free to do so, and we'd be happy to help you out. So yeah, as I mentioned, we're going to get into a little bit of our detection only product today. So we're going to be focusing on just the basic local features, get it up and running, exactly how to configure it, things like that. I'm going to show you an exact example. So we'll go right into Traffic Link and we'll do that example. I'm going to talk a little bit at the end about over-the-air update process. This has been coming up the last few months. I've heard it from a few of our users, so I want to touch on it a little bit at the end, and then I'll make sure I work through any remaining questions that are at the end there too. So just a quick overview. Many of you probably have heard different variations of this, so I wanted to kind of clarify to the customers on the call today what we mean when we say detection only. As you know, we often couple our system with software subscriptions. We have a software platform called Traffic Link. We often leverage the cloud-based tools and the remote-based tools that are based on the connected version of our device. But there is a detection-only system that is 100% local in the cabinet. You can configure it locally. You can connect to it. You can use everything in the cabinet as designed. So you get kind of a couple options when you're actually purchasing our product. You can use the detection only version standalone system at the side of the road, or you can connect it and use all of our software subscriptions. So when I say detection only, what I'm usually referring to is a system that you see here. You see the three Myovision devices, the SmartLink on the left, the 360 camera in the middle, and the SmartSense on the right. That's our video analytics and processor. And then our configuration tools, our local tools on the device itself. So with that in mind, these are basic functionality for presence and pulse detection. You can set it up for the zones, you can draw the zones, you can configure it. You do have, when it is connected, you do have the ability to use the Traffic Link platform for configuration as well. Gives you a few more features when it's connected, but you have to provide the communication mechanism for the Traffic Link cloud to actually use some of those enhanced features, but actually using the detection only features are local in the roadside local configuration tool. We do have a local API, so if you were connected into say an additional system, often what Myovision does is something like an adaptive system. You can connect our detection directly into that, or you can even just over your own communication mechanism get a real-time data feed from our system through our local MQTT API. So you can take advantage of that as well. That's on the device directly. Usually what this is used for is for the detector events, so you can actually make use of those beyond just actuation at the intersection. There is, similar to the data side, there is a video stream, so the RTSP feeds video API on the device. You can access that if you have provided a connection to the device. You can also leverage it if you just simply plug in your computer to the device locally in the cabinet. I'm going to show you some of that as I go today. And then the last item that comes with our detection only product is over-the-air updates. So while I did talk a lot about the local tools there, we do continuously maintain that connection for the purposes of updating that of the algorithms and the detection capabilities locally, so that it always has the most up-to-date algorithms. It has the best understanding of what vehicles are today. Our detection system is a machine learning system, so the more we deploy, the more these systems learn and understand of what vehicles are, what environments they're in, like winter to summer. Varies the image quite a bit, and our system has a machine learning process where it's constantly learning about how to adapt to those conditions. So with that in mind, we constantly provide over-the-air updates to make sure it has those performance improvements over time. So it's not a static device. You do get the benefits of those updates without having to pay for a subscription and so on. So we're going to be focusing a lot on just what the detection system is today, mainly on getting it up and running in configuration. So quickly, when I say roadside configuration, this means plug into the device locally with your laptop. It does require a laptop. I've never really done this with a tablet, but I guess that could work too if you have a tablet and you have a way to connect to Ethernet. But you can connect to it. You can log into the device, pull up the video stream on your computer without the use of our cell, make edits, configure the intersection as you want, get it up and running and drive away. This is a great tool for contractors or kind of third-party groups that are supporting your signal operations. This allows them to locally access the device and make changes without you having to provide them a cell connection or platform access. You could simply just give them the login details for the device locally in the cabinet. So just a quick overview of how to connect into it. I'm going to quickly cover that because I can imagine if you're out on the streets or you're actually looking to take advantage of these features, you will want to know how to log into it. First step is actually giving a password to the device. Security is a major element of our systems. We have a security team. We focus on security a lot, and we also focus on permission levels so that only certain people do have access to a lot of the different devices and a lot of different access points. And you want to make sure that these passwords are pretty robust and only given out to a certain number of people. So when you go into TrafficLink, so we have to actually set up a password for all of the devices. They do have all the same password. So that means when you log into a device, every device on the roadside will have the same login and password. So that you can give that to a contractor and the contractor can say install a series of these intersections on the same password and the same login. So that way you can maintain a security level in the cabinet as well as a security level in the cloud side if you are connected to cloud tools. So you have to make sure you set up a password for all of the devices, and once the devices have a password, you can actually log into them. It won't actually allow you to access the devices unless it has a password. That way we can maintain a level of security. That way no one can just get a device out of the box and plug into it and you'll just have access to it. You have to actually set up the password first. So again, just quickly, it's over Ethernet, so when you plug it into your laptop and then you go over to the SmartSense device here on the right, you can see we're just plugged into a open port on the SmartSense device. So you simply connect your device over Ethernet to your laptop. Because IP addressing is a big part of it, you have to make sure that you are on the same IP address subnet, on the same static IPs. So you have to give your laptop the same IP range. All of our devices at MyVision are 192.168.0.xxx, whatever in that series. We use the lower numbers for our devices, so .10, .20, in that kind of range. I usually choose just .111, just throw it up higher into the higher range and you won't have any issues. Technically, you can give anything, just above 100 is a good recommendation. And once you're on this subnet, it's super easy to just go to your Chrome browser, type in the IP address of the SmartSense, which is 192.168.0.20, and then it'll take you to the login page that looks like this. Then again, you add in that admin username and your password, and you can get right into the device and start configuring on the local tools. So there is a help article, there is an install guide and a configuration guide that actually go through some of these steps in a little bit more detail. I'm actually going to use this tool shortly in a second to show you how you can configure with it. So I'll just quickly back up. So step one is actually, I guess, make sure there's a password set in TrafficLink. That's a precursor. Then you step one, connect it to your laptop. You set in a static IP address on your laptop, go to the Chrome browser, go to the device itself at the IP address. This IP address can be configurable. This is just what our default one is. And then from there, you can log into the device and start configuring. So that's just how you access the local tools. If you're interested in actually understanding the local tools a little bit better, let me know. I'd be happy to jump in and make sure your devices are set up and make sure you know, make sure you have the team members that you want to know are also in there. So, all right. Oh, that's not a thing. All right, so let's go over to TrafficLink. So trafficlink.myovision.com is our tool set, and I'm going to quickly just log into the device locally in my demo cabinet, just to show you a quick example of this. I'm using that's I guess an important note. Because configuring detection is, you're often accessing a live intersection or a live device when you're doing it for your intersections or out in the field. I'm doing this on a cabinet and a device in my lab, so I'm doing this in a safe environment, not at a live intersection. So it's important if you're learning how to configure and you're learning how to get involved with the devices. I recommend not doing that on a live intersection until you're comfortable with it. You can do some things if you have a cloud subscriptions or a connection to the device where you can make edits or drafts of a configuration and then just go to the draft later on, and you can deploy it out or just save it from there. So we're going to configure this intersection a little bit. I did set it up for the local access. So up here in the top right, when I go to my admin settings, I added a roadside password. So again, top right, if you're an administrator of the account, you can add a password so that only this password can unlock the device locally and get access to it. Make sure you set, it has a specific set of requirements. I don't know if you saw that in the last slide, but it does make you set a pretty robust password. Yeah, so I already set mine up here just to kind of because it's kind of hard to show a local tool in a web browser during a webinar. I actually set it up as a device in the device pages of TrafficLink. So I'm going to access the local device through my cell connection that I have to it, just to show you what that application looks like. You can similarly do this type of connection. So I'm connecting to the roadside tool. I'm connecting to the roadside tool as if I was plugged in with my laptop right now. So I have my username and password that I have to fill out here that I will in a second. But you can also do this with, say, like a traffic controller or any third-party devices that are that have IP base, and you just simply want to access them remotely over the connection that is provided. So if you were, say, on a fiber network, as an example, like you have a detection-only system, you connect it to your local fiber that is already at the traffic cabinet. This will be similar to the experience that you'd have. You'd be able to go into the browser and log into the device over your fiber connection and get access to the device there. I just got to remember my password. Hopefully I got it right. Oh, sweet. So there we go. So I logged into the device. You can see this one's in my lab. I got a little video loop on one of the cameras that's connected, and just a picture of the cabinet in my lab here. So you can kind of see Myovision's office a little bit in there, which is fun. But I'm going to do the configuration on the looping video that I have, so that we can play around with the configuration a little bit. Just a quick tour. So once I did log into the device, you can see that there is 3 tabs along the left here. There's video streaming, there's configuration, and there's the turning movement count. So I'll go through each one of those in the session here and show you what that's all about. So quickly, let's go over to the video streaming tab. If you are actually at the side of the road, or say you're responding to a detection issue or a scenario at the side of the road, you just needed to see what is the system doing. I just want to see the live feed. This is the experience you'd have. You plug into the local SmartLink and SmartSense, and you'd be able to watch the live stream simply over the connection without needing a cloud access. So if you quickly see the detection overlay, theoretically you could connect this into other devices in the cabinet like a monitor, and you could see it there constantly. There is no self cost to that, so you could technically do that if you can configure it and connect it to do so. I have seen it work once in a lab where the new Cobalt controllers actually allow you to stream video to the front panel of them. I have seen that work in a demo environment where you can actually connect our live stream into the controller front panel. So that could be a fun little experiment. But generally just plugging it with your laptop is easy enough. Then there's the configuration tab that we're going to spend some time on here, and then the turning movement count export. So one big point on the turning movement count export, because I'm not really going to get into it too much today, I'll spend 1 second on it. We do have local turning movement count data that's stored locally on the device. You can export the turning movement count up to 90 days directly off of the SmartSense without needing a cloud subscription or a cloud connection. So this allows you to, if you so wanted to, you could drive around collecting your turning movement counts and not need the cost of a subscription. So it does save you some time, but you're limited to about 90 days worth of data, and otherwise it's not saved. So this is a handy option to use if you're on a fiber network and you just want to download some simple reports. The experience is actually kind of similar to TrafficLink. You can go back. It does have the same window view and the same date selector, but really it's gonna time you out after 90 days. So it only gives you a 3-month window: July, September, and so on. Let's click on the date here. When you download that, it just puts it into a CSV, and away you go. So let's go back to our configuration tab. Again, this is just the tool set locally on the device in the cabinet here on the right. So it is slightly limited compared to the cloud version, but you'll see as I go. So we're going to configure. We're gonna play around with this configuration here. So we're gonna use this one. First step, I'll go through the 3 steps of configuration. Hopefully that gives you an idea of what to do. So first step here is called configuring the camera. Configuring the camera is more about giving it a starting point. If you've ever heard the terms learning period or initialization periods, things like that, my version doesn't actually have it works right out of the box. It knows what it's looking for, but you have to give it a starting point. And so the purpose of this step is actually to give the camera a starting point where the system knows what the expected size of a vehicle is, and then it can auto calibrate around this step, and then you're out and running as soon as it turns on. So it's really quick. It's just a 2-minute step, and then you're out of the box operating. So the purpose of this step is to give it an idea of the curvature. So what I'm looking for is to line up straight lines, trying to tell the system what is the curvature, where is the center point of the camera, essentially what is the exact spot below the camera, aligning some of the curvature of the lens itself, being a 360 lens. So if you look across to the building here, you can see the line is pretty close. It curves with the building to some degree. I can stretch it out. You're looking for basically vertical lines are lining up so that you get the curvature right. So you can see how the vertical line here on the bottom left doesn't quite line up. So I want to back that up a bit so it follows the vertical line a little bit closer, which it looks like we're a little bit closer there, maybe a little bit far to the right. Doesn't have to be 100%. This step, don't stress over it too much, just has to be close enough. So we're close enough vertical lines here. Hit continue. One of the more important steps is actually giving it a sense of what is the expected size of vehicle, like almost a direct measurement of what that is. And so we take this little car, move it around, and put it on top of the vehicle, estimate the size. If you know the exact size, great, go ahead and do that. Just put it in, we'll hit continue. Because we're in the local device configuration, we don't actually have access to the cloud tools like Google Maps or location data, things like that. So we don't necessarily know what direction the camera is facing, and we can't use some of those APIs. You have to actually just give it a direction. So it asks which way is the camera pointing, and it gives you a toggle of what direction. We're actually on the northeast corner of the camera, so we're actually looking to the southwest corner of the intersection, directly across. So it's pointing at the corner, which means to the left is going to be south side of the intersection or a northbound approach. To the right is our west approach or eastbound traffic. And so we're going to use that as a concept as we work around the configuration. So that was setting up the camera. 3 steps: camera configuration, height of the camera, and direction it's facing. These steps really help us in terms of detector configuration, which is step number 2 here. So I already had a couple zones drawn, which is okay. I'm just going to go ahead and delete these because we'll rebuild them. So the TMC there, that's fine. So let's go to this approach over here on the far right. I think I always focus on the left one, so let's do a different approach on the right here. So when we want to configure, the first step, it kind of takes you through the steps here on the right. So if you actually just read along, it will guide you through the configuration. It's pretty clear on what it's asking you to do, pretty easy to follow. But make sure you just read what it's saying and you adjust as needed. So when we're looking at this far approach here, it is saying it auto-selected an approach for us based on that direction label that we set. If we take that and look at it, this is actually the eastbound, so it actually did it right. It said, yes, this is the eastbound traffic. You can change the label of this if you want to. It'll be that label that goes on the video overlay later on. I can hit continue. Now we want to just simply draw our zones. So we have our detection zones. I'll scroll that over a little bit. Drawing a detection zone, you can see you can add as many as you want. And it tries to auto guess the curvature and tries to place it on roughly the expected size of the lane for you. And it does auto adjust and proportion itself based on where it is in the frame, based on that first configuration step that we did with the camera. So it's trying to do a bunch of the work for you. It's trying to align the zones as much as you can to what it is expecting them to be just based on the configuration. So what you want to do is actually start drawing those zones, and you can tell we're not actually labeling detection channels just yet. We are just drawing zones at this point just to give the lay of the land. Couple points on how to draw detection zones. We're looking for scenarios where you kind of want to account for driver behavior. So if they're driving up past the stop bar and you still want to provide detection for them right into the crosswalk, you certainly can do that. Or you can almost penalize them for leaving the zone going in front of the stop bar. So it all depends on how you want your intersection to operate. Similar to on how far back should the zone go, you want to make that based on your timing plan design or your intersection design. If you make the zone too short, you may have a higher frequency of gap outs or a higher frequency of drop calls or drop-in calls because the space between vehicles are larger and you're terminating the phase earlier than you expected. Very often, the typical size of the zone is about 3 car lengths. When you have 3 car lengths, you're usually accounting for a gap out time that would have to start spreading out beyond 3 cars, and then the intersection will terminate the phase. But it all depends on your design. 30 feet is a very typical distance that I hear. For left turns, if you have them offset from each other, that's fine as well. You can simply just draw them in the appropriate spots. You'll notice that there's these green and red arrows. This does indicate directionality. We are expecting a vehicle to be going in a certain direction. So they're starting from essentially from the direction of the green towards the red. If they're going in the other, if they turn towards the right or turn towards the green here, it will drop the call or not even place a call because the vehicle is clearly not going in the right direction, and our filters just ignore those vehicles. That helps with almost this exact example that we're seeing here. There's a van coming across the zone, but because it's going in the wrong direction, it's not going to place any false positive or any calls on the zone. So having the directionality filters and having the ability to having the directionality filters keeps the noise down and minimizes false calls. So that's what those colors mean. They're about directionality. If you have say like a gas station or one of those little side ramps kind of really close to an approach that you do see a lot of noise from cars coming in from the side of the zone, that's okay too. As long as the car comes in from the side of the zone, and turns towards the green or turns towards the red, that's how we place the call or not, depending on which direction of travel it's going. One thing you'll notice is that there's a little bit of a signal pole right through the middle of our zone. A minor obstruction is not a big deal at all. We are accounting for that. Minor frame collections is okay, so that if we know where the vehicle was, we know where it's going. We can use some predictive analytics to smooth out our detection calls because it's only a minor blip of a signal pole. You can get into some scenarios though where your angle is too steep or you're directly across from an approach. And if you can think about, say, a large bus being in this zone, we only have a small zone to actually identify the vehicle on the one side of the bus and potentially only a small zone before the bus. And so you want to make sure you have enough of the frames or enough of the view of the approach that even when there's large obstructions in the view, there's still enough of visibility for the other lanes. If there's zero visibility to the other lanes, we'll start seeing detection performance issues. We can bridge it to some degree with the predictive analytics. However, it's not. I think there's the funny joke is it's not an X-ray camera, so we can't really see through the objects. But we can be pretty clever about it if we can see enough of the frame. So just watch out for too much occlusion. If there's too much occlusion, the best option is to simply get a second camera that can see it more appropriately. And so don't be too worried about occlusion. Most intersections have most intersections can see it fairly simply, and we can see enough of the stop bar and we can see enough of the front of the cars to place detection. So if that becomes a problem or you feel like there's too much occlusion being caused by a lane, second cameras or a different camera placement to accommodate some of those are helpful. So where's my approach over here? I have heard a couple questions in the past about configuring on live video versus the static image. We do configure on the static image today, and we do have some plans to do that on live video because sometimes watching the behavior of a vehicle while you're configuring is kind of helpful. You can really see what they're attempting to do, and then you can almost draw the zone while they're moving. That's something we're working towards. We're not quite there yet, but it is a great idea, and it's something that we're going to add into our platform shortly. So once you got your two vehicle zones down, we've talked a little bit about how to minimize occlusions with the physical camera, directionality, just getting the zone, kind of going from lane marker to lane marker. Don't overthink overlaps. Don't overlap the zones if you can. We like to do the center line of the vehicle to the center line of the nearest zone for lane assignment. And what that really means is that in our algorithm, when we look at a vehicle, you can see you see the image as a 2D image. So we have to calculate what the wheelbase is and what the projection of the vehicle is actually in the zone, not the 2D version of it that spills over into the other lane. So when we do our calculation, we actually create a center line that maps to the same projection of the road itself to give us a very accurate picture of which lane the vehicle's in. So that means when a vehicle comes up, we're automatically knowing where the wheelbase is and we're assigning it to the nearest zone. However, if you overlap those zones, the system will be unsure of what zone the vehicle is in. And if they're overlapped, it may give you a flicker effect. So it just kind of toggles between the zones. It's not actually sure which zone it's in because the center line is overlapping with another center line. So try not to overlap your zones. The only exception to overlapping zone is classification based. We do have the ability to do a classification based zone for, like, say, bikes as an example. You can do a zone specific to bikes. You can overlap that with a zone for vehicles as long as the same vehicle zone doesn't also include bikes. So you can separate them out based on classification. I'll show you what that looks like in a second. Last box that we'll add here is the pedestrian crosswalk. The crosswalk is typically used for counts in our count tool. However, we have been exploring pedestrian extensions from the crosswalk when you have, like, say, large volumes of pedestrian in the crosswalk and you're really looking for those extensions. How do I add more time to the signal if there's large groups crossing the signal, similar to what we saw here in this intersection where the population is pretty insane right outside of Union Station. But in any case, you draw the crosswalk zone, you'll notice that there's duplicate arrows on both sides. This is because this zone actually is looking for pedestrians going in both directions. It allows us to count how many there are and which direction they're going. And if you're interested, we've also been doing extensions based on pedestrians still in the zone. Doing pedestrian zones as a push button replacement from the corner of the intersection. So if say it was something like this, but smaller. That is something we're exploring, where we are using. We do have a couple pilots going. The only hesitation we have is if our counts of pedestrian are 98% accurate at high volume, and we can see a lot of pedestrians, and we're at a 98% level of detection and counts from the crosswalk. That's a pretty nice number for counts, but when it comes to push button and safety of pedestrians, that 2% error rate can cause some missed pedestrians, and we're piloting the impact of that. In many cases in our pilots, we've actually done pedestrian actuation from the corner in conjunction with a push button. So if say they didn't push the push button, but we detected them, it would place the call to the controller. Or conversely, if they did push the push button and we did detect them as well, we're just a data point on top, or a redundancy on top. And that does create a happy middle between things like push buttons and video operating together. And where that does become helpful is when you're doing more vulnerable pedestrians, or you have the audible push buttons and the audible tones that are needed for many states today, and many cities in Canada as well, where the audible tones are requirements for intersection safety. So if you can couple a video detection system with a pedestrian audible button, it's almost like the perfect mix of technologies, making it so that a call is never missed and giving the opportunity for a call to be placed. So those are things we're exploring, and we're starting to learn about how our system operates from the corner. We're fairly comfortable with pedestrian extensions from the crosswalk, and then obviously our vehicle detection is our main tool out of this whole system. So we got the zones drawn. We'll hit continue and go to the next stage. Crosswalk's pretty simple to finish. The last step is just where is it in the intersection? It's at the west side of the road. Okay, done. So let's go back to our vehicle zones. Vehicle zones are actually where you label the system, and you actually give it a detector channel. So this is the channel that would match on your traffic controller side. So we're doing here the eastbound left turn. Let's call it, just for the purposes of simplicity, let's call this phase. It's a left turn, so it's on number. Let's just say phase 3. I want to say this is a left turn. You can see it automatically labeled on my image over here on the left. Detector input based on classification. So this is what I was saying before about you can do it based on all vehicles, so bikes or motorized vehicles. You can do it based on just on motorized vehicles, or you can do it based just on bicycles. That way you have a few options here. There is some pilots on the go with things like buses. Like, could you provide things like pseudo transit priority through a bus detector? Often you're already at the intersection at that point, so maybe a preemption is not really the right way to think about that. Maybe you could just do a bus only lane type idea and provide detection just to a particular classification. But here you can either choose either all vehicles, bikes, or motorized vehicles. From there, you can choose if it's a presence or a pulse detection. So if you're actually looking at, I want a presence detector zone, or I'm going to try and do an upstream detection. At the moment, we can't go too far upstream or behind the intersection because of the distance our camera can see, but you can put pulse zones from within the intersection, or you can put pulse zones where you can see them, or where line of sight does work for the distance. MyVision is working on an advanced camera to complement our 360 camera, so that you can simply input advanced detection as well from our processors. If you do have existing detection at the intersection, you can just leverage that in the same way you would. Connect it to the detector rack. Often we see loops as those upstream detectors or radars. that's fine. We can coexist with any detection system. We just need to make sure we're not overlapping any channels. So MyoVision is on detector rack 1 here, so we only have channel access 1 through 16. You can open it up to have 1 through 64, but when you're coexisting with other detection systems, you would want to put one detection system on a series of channels and another detection system on the other channels. And so that way you can just kind of separate yourself on the SPLC connection from other systems and minimize conflicts between the systems. But if MyoVision is the only detection system, then you can just open it up to all 64 channels and away you go. So we said phase eastbound left, phase 3. We'll just say SDLC detector channel 3 as well. And then on the traffic controller, you would associate detector channel 3 with phase 3 as well. That way you have phase 3 labeled from MyoVision, you have channel 3 for detection, and in your controller you have phase 3 and detector channel number 3 all put together. For each detection zone, you can decide if you have a delay or an extension on it. If you want to create that type of operation, sometimes maybe do that on a left turn, maybe do an extension on a left turn. But often we see the delay being used on right turns or movements that have a lot of yielding traffic versus actual stop controlled. So we'll just say that's channel 3 presence, no delay or extension. There is a little toggle here called virtual actuation. If you're in a scenario where you don't necessarily need MyoVision for the purposes of actuation, but you do want MyoVision for the purposes of data, you can actually decide, I just want this detector input for the purposes of data. I actually have loops running at this intersection, so I'm going to use MyoVision for additional data points, and then you can configure us virtually. So we're not actually telling the traffic controller anything, but you're able to aggregate data from it. That's a tool that's often used for the cloud detection or the cloud tools side of it. You don't necessarily need to use this for any local operation. So that zone is done. Let's go over to our other zone. This was our eastbound. I said that other one was 3, so this would have to be phase 8, 7, and 11. Eastbound through phase 8. This is our through. This actually has a kind of a permissive right turn, I guess. So it's a through right. Again, all vehicles. It's a presence detector. This time I'm going to add a little bit of a delay, a 2-second delay in case there's a bunch of right turners going. But with this many pedestrians, we're probably not seeing a whole lot of people. Not seeing a whole lot of right turners just going because of the pedestrian volume. But in any case, we have phase 8. I'll select phase channel 8 as well to continuously be 1-to-1. That's just something I do for simplicity. I make channel and phases try to match as closely as possible. So when I think of phase 1, I think of channel 1. But obviously, you could have way more complex designs. You can have multiple channels to the same phase on the traffic controller. So you can program all of that accordingly on our side. When you're in a basic 4-phased intersection, I often think of it as a 1-to-1 channel design. But in any case, so that zone is configured and we hit done again. So now we have our pedestrian zone, our vehicle detection zones, both done for this approach. Now I saved that, now we can see it here as well. So let's just do quickly one more. And then I'll probably go for another 10 minutes or so, and then we'll wrap the session up a little bit early. Because I think I originally only planned to about 2 o'clock today, but because we had a late start, I'll go a little bit longer. All right, so we're going to do this next approach. This is our southbound approach. We do have 3 lanes here, a left turn, a through lane, and a through right lane. So we'll configure them into our system here. So this time it didn't get our approach right for whatever reason, so we'll simply change this to our southbound traffic, make sure our labels go accordingly, I'll continue. Now we can draw our zones. So I want 3 zones, 1 for the left turn, 1 for the through zone, and 1 for the through right zone. So let me just size these a little bit better. The idea of the auto placement of the boxes and the attempt to adjust them automatically is we're trying to save time. We want it to be a quick configuration. We want it to be easy to do. And you can get up and running as fast as possible, especially if you're at the side of the road. You want it to be really quick and easy. And Simple, just like that. So you should be able to get it up and running fairly quick. After a few runs at it, under 30 minutes from start to finish is usually what we see technicians able to do. This is a right turn, so let's just for fun extend that out a little bit. So you can see how simple it is. You just simply need to understand how you want your intersection to operate. What is the expected zone size that I'm programming the controller for, at least, or at least what I'm expecting for the outputs to be on phasing. Extend that out a little bit more. Let's add a crosswalk again. And notice with the crosswalk zone, I am going curb to curb. That's really for just getting the full range of that crosswalk. You could add some margins to it, but that's fine. You'll notice here I didn't overlap any of the zones. I do know that they're actually not on this approach. Maybe it was on maybe not this intersection. But say for an example, I did mention this earlier where you could have overlapping zones in terms of, say it was for a bike zone. So say we had a little sliver of a bike lane on the side here that was a little bit of a shared lane for the vehicles as well. Often when you have a bike lane, they're a little bit more separated. And so let me just edge this in a little bit. Let's pretend for a second that there is a bike zone right there. So we'll put that zone there as well. You can overlap these ones separately because we're going to configure them based on classification. And they're going to be exclusive of each other. So we've got our zones in place, so let's quickly configure them as well. This is our southbound left phase, let's call it phase 1. We're going to say for this one, no delay, nothing. This be our detector channel 1. We'll go to our center lane. I did do a zone per lane here. There is a scenario where we could have just done one zone for the entire approach, because now we have to use an additional detector channel. Whereas if I say I just did the southbound through phase 6, say we just did one zone, this would be easy to line up to channel 6 on one particular zone. But now we have center lane type design. So this is exclusively a through. Again, just a presence detection. We don't want any delay or extend. We'll go to the same one. This is also our southbound through phase 6 curb lane. This is our through right. We're going to put a slight delay on this one. This one is going to be specific to motorized vehicles because we have a bike lane zone there as well, and we don't want to confuse the two zones. But because I've chosen an additional zone for this approach, we need to just simply use a different detector channel. So since we're on phase 6, I'm just going to jump up to detector channel 4 and just offset by essentially 16 there. Or sorry, essentially 8 there. So we'll do that one, and then we'll click on our bike zone. This will be southbound bike zone on, I guess this is phase 6 as well. We'll do through right again. This though is specific to bicycles. It's a presence zone. We won't put any delay on it because bikes generally move slow. So let's just let them get their detection call. But again, we need a different detector channel because we're kind of using the same thing here. I'll just choose 15 for the purposes of simplicity. But one thing you'll notice as I'm going through here is we can't necessarily do this zone and this zone equal the same channel. So you can have more than, each zone can't have more than one channel. And one channel can't be reused more than once either. So what that means is we have to make sure we do one zone to one channel, and then we can input that to the controller pretty easily. And so for the purposes of this, I just jumped up to a different channel set so that we can add it in. Hit down on that. So now we have our left turn, southbound left phase 1 on channel 1, southbound through phase 6 center lane on channel 6. We have southbound through phase 6 curb lane on channel 14. Then we have our southbound phase 6 bike zone on channel 15. We can then go to the traffic controller and program those channels to the correct phases on the controller side as well. We do have two zones here. The first one is motorized vehicles overlapped with a bicycle detector. So now this zone on the front here, the motorized vehicle zone, will only place a detection call to the intersection if it is a vehicle in the zone, not a bike. This zone will only place a call to the controller if it's a bike and not a vehicle. That way we have no overlapping or confusing noise coming out of the channel. I'll hit done on that. Crosswalk 1 is done as well. So once all of those approaches are done, we can hit done again. So that entire approach is now done. We did eastbound and southbound. We would essentially work our way around the intersection as such. So I wasn't going to configure another one. Hopefully that helps you understand the approach configurations and some of the options, what to look out for in terms of things like occlusion or just artifacts in the video. Don't worry too much. We can navigate them fairly easily through the algorithms. So let me go back a step here. The last step is the turning movement count. This one is a little bit more simple. It's a little bit faster if you want to configure a turning movement count. And you'll notice that, I guess I already had this one here. But basically the way it works is you draw the box, or you get this one box, then you just size it accordingly to the entire intersection. I usually go curb to curb, including the crosswalks, so that you'll see why in a second, because it actually draws tracks on the overlay here, so you can see which way people are driving, which way they're going, and so on. You want to make sure all the labels make sense. So northbound, southbound, eastbound, and westbound are all in the right spot. If they're not, you can rotate them. We'll hit continue. Similar to the same concept of the detection zones, red is out, green is in, and we'll line up tracks to these in a second. So you're really just establishing what are your ins and outs for the turning movement count. Line these boxes accordingly. We got each one of them again. Just go curb to curb. You'll see when I go to the next step how it draws the lanes. Why you don't need to overthink it too much. But really just on your ins and outs for each approach all the way around the intersection. I'll hit continue, and then it automatically draws all the turning movement count lanes for us. And so if we look at the southbound one here, we can see that there's 2 through lanes. We drew an individual track for each one of those lanes to be used, a right turn lane, and each one of them are labeled as I go over them. If you do have multiple lanes, I do recommend you configure a track for each one, so you can simply add a new movement and have a line for each lane that can make the travel. This is a little bit more for the purposes of analytics. So if you're not using some of our safety features, this may matter a little bit less. If you're using it just for basic turning movement counts, a single line for an approach will be fine. But generally, as a standard practice, I just add a movement for every lane essentially. So we just work our way around each one of the approaches. So we have westbound here. We'll move that over slightly. Our left turn's a little bit off. We'll kind of make that match a little bit. U-turns, we do collect U-turns. They do go wider than you expect, so make sure you just draw the lane to match as close as possible to what the actual field of travel is. But you just work your way around, make sure all the lanes make sense. They look a little bit reasonable. And when you're looking at the video overlay, this will be the purple lines that actually match to the indication that a count has been taking place. So yeah, working your way around, kind of looks reasonable. Once you're happy with that, you hit done, and then you can simply hit deploy. So on the bottom right here is the deploy option. It deploys the configuration that you just did out to the intersection and makes it operational essentially immediately. So if you're on your laptop at the side of the road, you're up and running immediately. When you do turning movement counts, we have this idea of track overlay. This track overlay actually monitors the volumes to some degree so that we can actually put a heat map over top so you can actually adjust the lanes afterwards. So if you come back in a couple hours after you configure it, I guess we say a few hours here, you can come back and make any adjustments you want to it to match the exact travel patterns that occur at the intersection. So I'll hit deploy on that. Oh yeah, this is a test intersection. So because I'm not actually connected to something here, it didn't actually let me update it because I can't actually tell anything to it. But let's go back to our video stream. And we'll just take a look at what we did here. Oh, I'll go to the detection overlay. this load up quickly. And so then it goes live. So I think my tool timed out on me there while I was in the live session. So there we go. We can now see just what the configuration is. We have our turning movement count, some of the zones drawn, and away we go. And then you can basically watch that live at the side of the road and make any further adjustments. I often like to check in a few times. If you have a cloud connection, that's a lot easier. Sometimes you may have to drive out to actually look at it. So that is configuring for detection and turning movement counts. All right. Go over here. So one of the topics I just will quickly talk about, and then I'll wrap up the session and see if there's any open questions. But one of the main topics that I didn't quite get to today was over-the-air updates. MyOvervision does do over-the-air updates, usually about once a month. Once a month, we send out a message saying your devices will be updated, or a particular device like a SmartLink or a SmartSense will be updated, and you will get a notification 48 hours in advance that this update will occur. There are two different ways to get this notification. If you are logged into the platform, you'll see the pop-up 48 hours in advance. If you wish to be on an email subscription of that, so you get emailed into your inbox, let me know, just reach out. We don't do that by default because you have to opt into it. So let us know. We have been starting to do some outbound emails to make sure everyone is aware when we are doing updates. When an update occurs, we push the device down to the devices. We don't do it all at once. It happens very slowly. So even when we say we're updating the devices and say you have 5 devices, it'll actually update one at a time. And so if there are ever any issues with an update, it can be reverted, it can be stopped, and we can monitor it and make sure everything updates successfully. We don't do every city at once, and we don't do every intersection in every city at once. We stage it out over a period of time. So sometimes when we post the notification that we are doing an update, sometimes it takes us a full 24 hours to actually let the system work through those updates. And at the end of the 24 hours, it'll be complete and every device will be updated from there. So you want to be aware that it's not all at once. You do get 48 hours heads up that an update is coming, and we slowly roll them out. It happens in 2 stages. It comes down to the device first, and then once it's a safe moment to do so, it'll automatically update itself. The process of updating takes about 90 seconds. During the period of 90 seconds, the device will go into a constant call or a fail-safe recall, and it will continuously cycle the lights. And then as soon as the operation comes back to normal, it'll come out of the fail-safe recall after the 90 seconds and go about its business. If that's the experience, if you don't have that experience and it took a little bit longer to do that, it will remain in the fail-safe moment if it does take longer. We have seen it take up to 10 minutes in the past, and then it will reestablish the connection and then reestablish operations, all in a fail-safe mode. So it should operate safely at all times, and then go back to normal operation all automatically. And so we follow this process and we monitor it very closely. Out of 1,000 intersections that we would update over a 24-hour period, there is the odd one. So we sometimes see one device that didn't actually make the update occur and it reverted back to the old firmware. And then we would just go manually push it and get it updated. Manually, for whatever reason it didn't, we'll log that and we'll make sure it doesn't happen again. We watch fairly closely, and even in the worst case scenario, your intersection is still safe and the devices are always recoverable. So very small percentage chance that it doesn't complete the update and it just reverts back to the old version if it wasn't successful. So very, very quick, simple process. Watch for those updates, watch for those heads up. We watch very closely when the updates occur. You shouldn't be worried that it's ever going to be a citywide thing. It's a very slow process on purpose to make sure if anything does occur and say an intersection goes into a fail-safe, that it can be recovered fairly quickly and you don't need to have too much anxiety over it. It's a really nice process. The benefits are pretty powerful. Every time it updates, the accuracy jumps quite a bit. We see improvements to weather conditions, improvements to operation, improvements to classification in every one of our updates. In terms of detection accuracy, we're already well above 98% overall. Now we're just slowly closing the gap to 100% and getting more clever about detection. And it's getting really exciting, the power of machine learning. So if you have any questions about how that works, or if you want to set up some of your local tools, please reach out. Let me know how I can help. I'd be happy to help you take advantage of them. But yeah, I'll wrap up there. For those that are still following along, if you have any questions, let me know. I can answer them here for the next few minutes. If not, look out for our next session. We are going to get into the platform, the traffic signal management and performance measures. We're going to jump into more of the platform stuff next month, kind of show you some of the features and functionality there. We typically do these sessions once a month, usually on a Tuesday or a Wednesday. We offset a little bit this month, but we'll be back into a rhythm next month. Look out for those session signups. Yeah, just let me know if you have any more questions. Thank you again for hanging on and waiting out some of those technical difficulties. For anyone that did drop off, no problem. Thank you so much for coming. We'll send out a video of this session following this so that you can watch it on your time. Yeah, so thanks everyone. If there's no more questions, I'll let you go for the day, and hope everyone has a good day. Thank you so much. I don't see any questions rolling in, so I'll just end the session here. Thanks everyone. Have a good rest of your day.